The past 2 days, we have seen how to find zeros, y-intercepts, and the vertex in factored form. So now we're going to take all of that information and simply put it on a graph. Order doesn't necessarily matter, but I'll follow what I've got in the right-hand column. So we'll find our y-intercept first. Remember, the y-intercept occurs where the graph crosses the y-axis, and everywhere on the y-axis, our x value is 0. So we replace both x values with 0 and solve for y. So we get 0 plus 4 times 0 minus 2, which gives us a y value of -8. Don't forget to put that as an ordered pair because we will be putting it on the graph. We started off with an x value of 0 and solved to get -8 for y. Before we find the vertex, we need the zeros or x-intercepts. This occurs where y equals 0, so we replace y in the equation with 0 and solve for x. Remember, with a parabola, we could have our parabola cross the x-axis twice, so sometimes we get 2 x-intercepts. Setting each piece equal to 0, this is our zero product property. Equation on the left, subtracting 4 from both sides, we get x equals -4. Equation on the right, adding 2 to both sides, we get x equals 2. Putting these as ordered pairs, I solved and got -4 for x when I substituted 0 for y. Second one, I solved and got 2 for x when I substituted 0 for y. After I have the zeros, I can find the axis of symmetry, which will lead me to my vertex. So I take my zeros and add them together, dividing by 2. -4 plus 2 gives me -2, divided by 2 gives me -1. So the equation for my axis of symmetry is x equals -1. That also gives me the x-coordinate of my vertex. So I can substitute that back in for x and solve for the y-coordinate of my vertex. Running out of room here, so I'll have to work to the side instead of down the page like I normally do. So the -1 plus 4 gives me 3. -1 minus 2 is -3. So I get a y-coordinate for my vertex of -9. Your vertex is an ordered pair, so make sure you put that together. Our x value was -1, and we solved and got -9 for our y value. Once we have all of those ordered pairs, we simply put them together on the graph. So I'll start with my y-intercept, 0, -8. I had two x-intercepts, -4, 0, and +2, 0. And then I had a vertex of -1, -9. You can also remember that axis of symmetry because we have one extra point off to the right of our vertex than we do off to the left. So if you think about that axis of symmetry, you can flip that point over the axis of symmetry, and then you've got an even number of points on each side to make your nice, smooth, symmetric looking parabola. Example 2, same thing. We'll start off with our y-intercept. Y-intercept is where we replace x with 0 and solve for y. Order of operations, I'll simplify inside my grouping symbols first. Multiplying all together, I get -6. Writing my solution as an ordered pair, I started with an x value of 0, solved to get -6 for a y value. Finding my zeros next. Our zeros occur when our y value is 0. These are our x-intercepts. So we replace y with 0 this time and solve for x. This is our zero product property. We can only get 0 when we multiply if we're multiplying by 0. Looking at that coefficient of 2, 2 can never equal 0, so we don't use that when we're finding our zeros. We only use the pieces with variables. So I'm going to set my x minus 3 equal to 0, adding 3 to both sides. And then I'll set my x plus 1 equal to 0 and subtract 1 from both sides. Setting up my ordered pairs, I solved to get 3 for x when I substituted 0 for y. And my second ordered pair, x is -1 when I substituted 0 for y. After we have our zeros, we can find our axis of symmetry, which is averaging those zeros together. So we set up 3 plus -1 all over 2. 3 minus 1 is 2, and 2 divided by 2 is 1. So x equals 1 is our axis of symmetry. Once we have that, we can finish finding the vertex by substituting that 1 back in for x and solving for y. We'll simplify inside the grouping symbols first. 1 minus 3 is negative 2. 1 plus 1 is 2. 2 times negative 2 is negative 4, times 2 is negative 8. So our vertex, x, was 1, and I solved and got negative 8 for y. We'll put all those ordered pairs on our graph, starting with our y-intercept, which was 0, negative 6. Our x-intercepts were a positive 3, 0, and a negative 1, 0. My vertex was 1, negative 8. And if you'd like to use that axis of symmetry to sketch it a little bit more exactly, getting that point, that y-intercept, and flipping it across your axis of symmetry will give us an even number of points to aim towards when we're making our parabola. And again, make sure you've got your arrows on the parabola. It will continue, in this case, to increase forever on both sides. All right, I'm going to try and move through the last example a bit more quickly. This one, I noticed my coefficient is negative, so I know that my graph will open down. I'm going to think about that consistency when I graph. Y-intercept occurs when x is 0. Evaluating inside the parentheses, we get 7 and negative 1. Negative 7 times negative 1 is positive 7. So my ordered pair, x is 0 when I solve to get 7 for y. Zeros, or x-intercepts, occur when y is 0. Setting up our zero product property, that negative sign can never be 0. So we'll set the two pieces with a variable equal to 0 to solve. Left-hand equation, we're going to subtract 7 from both sides. Right equation, we're going to add 1 to both sides. Ordered pairs, negative 7 when y was 0, and positive 1 when y was 0. After we have our zeros, we can average them together to get our axis of symmetry. We'll take our negative 7 plus 1 and divide by 2. Negative 7 plus 1 is negative 6. Divided by 2 is negative 3. So x equals negative 3 is our axis of symmetry, which is also the x-coordinate of our vertex. So to solve for the y-coordinate of our vertex, we'll substitute that negative 3 back in our equation and solve for y. Inside the grouping symbols, we'll evaluate those first. We get a 4 and a negative 4. Multiplying those all together, we get a positive 16. So our x-coordinate was negative 3, and we solved and got a positive 16 for our y-coordinate. So looking at this graph, it does not go up to 16, so I'm going to scale each of these by 2 this time. My y-intercept is 0, 7, so again I'm counting by 2s. So 2, 4, 6, 7 will land me right here. My zeros are negative 7, again counting by 2s, and positive 1, counting by 2s. My vertex is negative 3, so counting by 2s, and then up 16, my vertex will land here. Sketching in that axis of symmetry, so I can flip that y-intercept across my axis of symmetry. Goes right down the middle. This time, my y-intercept is 3 away from the axis of symmetry, so I'm going to go over 3 to get that other point. The other ones, it was just 1 away, so it was kind of an easier flip. And our graph does open down, just like we said it should. And we need arrows at the bottom of our graph. Here's your U-Try question. Get as much done as you can and come to class with questions if you have any.